Hello, welcome to day 22, and in today's lesson we'll be looking at tuples and sets. In addition to the list collection, Python has tuple and set collections. Tuple are very similar to lists and they store objects of various types. However, what sets apart tuple from list is that tuple is immutable. Just like a string, since a tuple is immutable, there's a less functionality we can do with them. The tuple takes less space in memory. Whereas, as for list, this is represented with angle bracket. A tuple is represented by parentheses. Let's look at how some of this work. If you see what we have here, we have two ways of initiating our tuple. You can either use the constructor or you use the tuple literal. One thing to always understand about tuple is that once you create it, you cannot change the value. You can only reassign the value or create a new instance. Now, let's create our first tuple. We're going to say explicit tuple. Let's just give it some values so we can go ahead and say 1, 2, 3, then we can say A, then B. Okay, so we are doing this with parentheses. Another way we can create tuple is without the parentheses. So let's just call this one implicit. Then let's remove the parentheses. Now, this is still another way to create parentheses. Now, what we can do, let's even try to check the type. So let's print. Let's see what we get. Okay, so we're just going to run it by right-clicking and run it. Okay, so you can see that our value is being printed out. How about we use the type function? First save it and I try to run it. You can see the type of tuple. Pretty cool. Now let's see some of the methods we can perform with tuple, just like we did with string and list. I'm just going to take away this. Now let's set the count method. Alright. Now for us to check the type for us to check the count method, let us look at another tuple object. So let's say top. Let's use the literal. Then I'm going to have multiple of 1. Then let's say I have multiple of A's. Okay, let's paste those. Now let's try to use the count method and see what we get. So I'm just going to say print. Then I want to reference the top. Call the count method. Then what do we want to count? So let's count 1 in the first instance. I'm going to duplicate, and let's count A in the first instance. This has to be a string. Now, if we run our code, let's see what we get. So now, if you count, of course, we have 3 times 1, then we have another 3 times of A. Okay, so what happens when we reference a string or an instance that doesn't exist? I'm just going to duplicate this. Let's say we're looking for C, and let's say we're looking for D. Let's see what we get. You can see it doesn't show you error. However, it tells you how many times they exist. But as for these 2 instances, they only existed in 0 occurrences. The reason why you're seeing the value of 0. Another thing we can check with our method is index. Let's see what we can do with index. The index method. Okay, so similar to what we've written here, we can also reference, of course, there's our tuple here. Let's just call the print function. Then we want to call the top, call the index method. Then let's see the position of 1. Okay, we can also duplicate and see the position of A. See the index of A. Now, if we save it and run it, let's see what we get. All right. I think let's comment out this so we know the result we're getting. So now what Python is doing is grabbing the first position and is grabbing this as well. Okay. Another thing we can check is index slicing. Index slicing. Just say slicing. Now we're still going to reference our tuple, but in this case, let us do something different. We can comment out this one. We can just print let's call the tuple, but this time around, let's use our index slicing. So let's say we want the number 1, then maybe we want the number 3 and the number 5. So for printing, we should be getting this. Then we should also be getting this. Then we should be getting this as well. Let's run it. You can see A1AA. Cool. If you really want to know that we're sure of what we're getting, let's turn this to S. Let's turn the 1 maybe to 10. And let's turn the 3 to Z. You can see 10, which is of course the position of 1. Then Z, which is the position of 3. And finally 5 position, which is of course S. Cool. Let's just take this back to what we had. Another set of data type we can see in Python are sets. Let me just take out this one. Okay. Now, sets are also similar to list, but they differ from tuple and list in their unique values. Also, sets is unordered, Set in Python are represented by curly braces. There are two types of set: normal set and the frozen set. Let us take a look at what we mean. If you see the data type that we have currently, we've of course looked at list. We also learned about the tuple. Another aspect is set. Now, set gives us some sort of flexibility as well, and let's see how we can put it into practice. To create an empty set, we can only use the constructor. We cannot use the curly braces as literal because another data type, dictionary, is represented with braces. Thus, the literal are reserved for the empty dictionary. We're going to be talking about dictionary in our later course. Unlike tuple, a set is mutable. So creating an empty set is acceptable. Let's see what we mean. To create an empty set, you could either use the constructor, which can be maybe end set, then you just go ahead and say set. So this is the constructor. Right. Now, what I just explained is it is not possible for you to create sets like this. Right, because Python sees this as dictionary. If you really want to know what I mean, so let's call this nset1, nset2. So let's try to print the type. You can just call the type. Now let's run it and see what we get. The first instance is saying set, and the second instance is saying dictionary, even though what you see here is curly braces. So these are some of the things to take note of while writing your code. I'm just going to go ahead and delete those. Now let's write some of our sets. So it is possible as well that we create our sets with the add method. So let's say, for instance, I'm just going to use the add method. To use the add method, you can just, so let's reference this and set. Let's call this nset1. So we're just going to say nset, then call the add method. Then we can give it a value. So let's say 5. Let's say 7. Let's say string, we can say a. Then let's add more value. So we can go ahead and even add 1, then a. Now you can already see something complaining here. For this to work, you can also just add another parenthesis, which means before even the add is run, this should be calculated first. So this is just going to be merged. Now let's see what we have, right? If we try and print our nset1, what do we get? You can see we have a nested tuple in our set. Makes a lot of sense. Just going to comment that. Now, just as we've added a tuple to our set, is it also possible for us to add lists to our set? Let's check it out. So I'm just going to say n set, then call the add method. Of course, let's try to add a set. Let's try to add a list. So I'm just going to say 1, 2, then 3. Okay, so if we go ahead and run it, let's see what we get. So you can see unhashable type list. So it is not possible for you to add a value into, so it is not possible to add a value of list into a set. And the reason is really simple. It is possible for you to lists are mutable. In other words, you can update lists. But for set, they are unique values, and which means there are two things that doesn't work together. Let's take a look at another method. I'll just go ahead and, of course, comment this one out. Another thing we can do with set is to declare set with a literal. In other words, we can just go ahead and say nset2, just call the literal, and let's give a value 2, 3, let's say a. We can also say 1, then we can go with a again. Now, if we go ahead, just run the print function and say the nset2. If we run it, should be able to get our value. You can see, cool. Let's try to see another method we can use. Another method we can use is the remove method. You can use the remove method. Now with the remove method, just something similar. Let's reference our nset2. So I'm just going to say nset2, call the remove method. Now, once you call the remove method, what do you want to remove? Let's say we want to remove 3. Right. So let's run our print function. Nset2. Let's comment this one. If we run it, what do we get? So you can see on the list, the number 3 is out of it. So what happens when you try to remove a value that doesn't exist? So we can just say value that does not exist. So what we can do is, let's try to remove, we know that 5 is not on the list. Let's see if Python throws any error. Of course, you can see it's throwing us another error, making us understand that this number does not exist. Key error. Okay. The final method in this section is going to be discard method. So let's see. Discard Similarly, the discard method allows us to discard a particular section, a particular key. Let's see what we mean. Let's call the end set. This time around end set 2. Then call the discard. Sometimes you can always over to read information about a particular method. And if you see what we have here, it removes an element from a set if it is a member. In other words, if it's not, it will just return empty. It won't do anything. Let's see. Let's try to remove 5 that we use here that triggers an error. And let's see what we get. If you run it, you can see that nothing happened, right? Because it doesn't exist. How about we try to remove something else? Let's say we try to remove 2. Then let's also print and 2. So you can see 2 is out. Pretty much cool. Let's run it again. You can see 2 is out. Alright. Now that you have the understanding of how list, tuple, and set works, in the next lesson we're going to be looking at dictionary. Dictionary is another interesting data type in Python. In fact, it is the data type you often use whenever you're practicing your object-oriented programming. So see you in the next one.